Okay, we're looking at rewriting basic partial fractions at the moment. Ones where we've got nice linear factors on the bottom, and so if we've got a linear over a quadratic, I can just set it up as something over the first bracket, 2x minus 1, and then something over the second bracket, x plus 4. You tend not to get standalone partial fractions questions in A-level papers. Normally this is part A, where part B will go on to do a binomial expansion or go on to do integration, and we'll cover both of those later on in the course. So our setup's like that. As we looked at last time round, get rid of the fractions so we can find our constants A and B. So times by the 2x minus 1 and the x plus 4, and I get 14 minus x is equivalent to A times the bottom bracket there plus B times the bracket there, the 2x minus 1. And all I'm going to do is, since it's true for all values of x, stick in x is minus 4 and x is a half, the values that make each of the brackets equal to 0, and then so I've got 14 plus 4, 18 equals, that becomes 0, b times minus 8 minus 1 minus 9, b equals minus 2. Stick x as a half in, 14 minus a half, do its top every fraction because it's neater that way, so 13 and a half, 27 over 2 equals a times 4 and a half, 9 over 2, and the over 2's cancel out, a is 27 over 9, a equals 3. So our 14 minus x over the 2x minus 1 bracket x plus 4 just becomes 3 over the first one minus 2 over the second one. As I say, the question would then go on potentially to either do an integration on that or to do a binomial expansion on each of those and collect it all together. Second example, similar, but the only difference here is they haven't got the linear factor on the bottom. So the top, by the way, as long as it's a lower order and just a constant is fine. And at the bottom, I need to be able to factorise it. It's 3x and x, and 5 and 1. 5 is not going to be there, so the 5 is going to be here, and 1. I need plus 5 minus 3 to give me the plus 2. And that's going to be a over 3x plus 5 plus b over x minus 1. Get rid of the fractions. 4 is equivalent to a times x minus 1 plus b times 3x plus 5. Awkward looking numbers. X equals 1 is fine. 4 equals b times 3 plus 5, 8, which gives me b, 4 over 8 half. Be careful with fractional terms, as we'll see in a moment. X equals minus 5 over 3, still 4 on that side, and a times minus that, minus 8 over 3, and a equals minus 12 over 8, minus 3 over 2. And how I would write the answer then, with these fractional coefficients, minus 3 over 2 for a becomes minus 3 on the top over 2 bracket 3x plus 5, and then plus 1 over 2 bracket x minus 1. So the coefficients are there, the minus 3 over 2 and the half are written in that form there. Third example, exactly the same sort of setup where I've got to factorise the bottom, but in this case I've got, like we looked at previously, top every fraction, the order of the top is the same as on the bottom, so I know that when I do my division I'm going to end up with a constant plus something over the first bracket and then something over the second bracket, and the brackets are going to be probably 3x and 1 and 2x and 1, and how to get the plus 1 there, make that one plus there and that minus there to give me plus 3x minus 2x is plus x. So there's my setup in that case there. Get rid of the fractions as always, times by the denominator, 30x squared plus 6x minus 2 is equivalent to a times both brackets, 2x plus 1, plus b times the other bracket, 2x plus 1, plus c times the first bracket, the 3x minus 1. And I've got three things to find, three things to do here, so I'm going to be sticking in x equals minus a half first off, bit more going on here, although it gets rid of two other terms, a bit more to calculate in this case. 30 times x squared, 30 over 4, 15 over 2, and then plus, actually minus, because it's 6 times minus a half, minus 3, minus 2, equals, that goes to 0, that goes to 0, c times minus 3 over 2 minus 1, minus 5 over 2. What does that give us then? 15 over 2, 7.5, minus 5, 2.5, minus 5 over 2, which gives me c equals 1. X equals, what's the other value? A third. So we get 30 over 9, plus 6x, plus 2 minus 2, that cancels out nicely, we can simplify that, equals, that goes to 0, that goes to 0, b times 2 thirds plus 1, 5 thirds. So 30 over 9 is 10 over 3, the over 3 is cancelled out, b is 10 over 5, b equals 2. And the last one, to get a, match x squared up. 30x squared, and I've got a times 3 times 2, so a times 6 equals 5. So our fx then becomes 5 plus, get it the right way around, b is 2 over the 3x minus 1, and then plus 1 over the 2x plus 1. Okay, in the last example, also a top-heavy fraction, but where the order of the top is bigger than the order of the bottom, so my setup for gx is going to be cubic over quadratic ax plus b, I'm left with a linear expression, and then plus c over the x minus 1, and plus d over the x plus 2. So 4 things to find, a bit more going on with this one, and as before, times by the denominator, so I get x cubed plus 4x squared plus 7x minus 6 on the left hand side is equivalent to all of ax plus b times both brackets, x minus 1, x plus 2, plus c times the other bracket, x plus 2, and then, plus d times the first bracket, x minus 1. So at least I'm not doing fractional things here, so it's a little bit better. X equals 1, gives me 1 plus 4 plus 7 minus 6 equals, that goes to 0, that goes to 0, c times 3. And we work all this out, what have we got then? 12 minus 6 equals 3c, c equals 2. X equals minus 2 is the other one, so we get minus 8, plus 4 times 4, plus 16, minus 14 minus 6 equals, that goes to 0, that goes to 0. Yep, and then I'm left with the d term, d times minus 3. And so what have I got in this case? Lots of minuses. 16 minus 28 minus 12 divided by minus 3, d equals 4. Do the x cubed, because that's the only way I'm going to get x cubed is ax times x equals 1. And then anything else, I've got to use something else, at least one of these other 3 things I've found so far. I can have, x equals 0 is fine to get minus 6 equals b times minus 2, so minus 2b, plus 2c, plus 4, minus d, minus 4, well that's nice, they cancel out, b equals 3. And then all together, when I put it all as one answer, I get my original function g of x is equivalent to ax plus b, x plus 3, and then plus c plus 2 over the first bracket, x minus 1, and then plus d 4 over the second bracket, x plus 2. So, as always, because I've got a top-heavy fraction, I think about the order, so cubic over quadratic leaves me with the linear, and then because I've got linear factors on the bottom of the fraction, I'm just left with constants on the top. Get rid of the fractions first off, stick in values of x that make the bracket equal to 0, match up coefficients, and if you still need to, either find another coefficient or stick in another value of x for your last value or two at the end. And that's it.